Are you ready for RAPID TCT 2022? I am. I'm excited to experience all that is offered, including a show floor with nearly 400 exhibitors. On that floor, there is something for everyone. But, and this is a big but, you won't have enough time to have worthwhile conversations with all of them. And that's where I come in. I'm Todd Grimm, an additive manufacturing consultant and an advisor for RAPID TCT. What I've been tasked with is presenting the highlights of new solutions that you can explore on the show floor. The goals are many, but the prime reason is to give you a taste of what we know so that you can make sure that you get to the booths that have solutions that interest you. What I have for you are products in 5 categories: printers, software, materials, post-processing plus ancillary hardware, and 3D scanning from 29 companies. My goal isn't to provide all the details. That would take too much time. Instead, I'll offer the key highlights so that you can decide if there's something you want to investigate further. 2 more points before I dive into what's new. All the solutions that I'm covering were supplied by RAPID TCT exhibitors. The second point, there will be more announcements before and during the event. To highlight those so that you can keep up with the flurry of activity, I'll be taking the main stage each day at 8:15 before the daily keynotes to offer highlights of announcements that may help you solve a problem or meet a need. So let's get started with 3D printers, and I'll kick that off with metal AM machines in the DED, or Directed Energy Deposition class. And I'll start with Meltio, a relatively new company founded in 2019 through a joint venture of Additive and Signova. Oh, by the way, on the screen I've listed booth numbers for your convenience so you can find these companies in the show guide. Now, Meltio has 3 alternatives for you: Meltio 450, a standalone 3D printer; Meltio Engine, CNC, a module you add to a CNC for hybrid work; and Meltio Robot Integrations, a module added to industrial robot to expand the working volume. The company's second-generation deposition head offers single or double wire feeds. The latter allows you to build parts, repair parts, or augment parts with additional features using 2 distinct materials. The material changeover is handled by the deposition head, which has dual feeders that are independently driven. And that means that they're always at the ready to swap between one material and the other. There's also talk of a wire plus powder feed option, but you'll have to stop by their booth to get a better understanding of that. Also in the DED category is DMG Mori with its new LaserTech 3000 DED Hybrid. This hybrid platform offers 5-axis machining and DED in one chucking. The platform is a turn mill machine, so the subtractive operations can either be turning or milling with onboard storage of 38 tools. Its capacity is parts up to 400 millimeters in diameter by 1.3 meters long. That's for the DED deposition aspect. On the AM side, it is a powder-based metal additive process. It's outfitted with a 3 kilowatt laser, and it has multi-material capabilities, either in discrete or mix-on-the-fly modes. The machine comes with AM Assistant for process control measures like melt point temperature, powder supply calibration, detection of cutting chips on the powder nozzle, as well as quality inspection tools. And DMG Mori is bringing additive intelligence to the US. No, it's not saying that we aren't intelligent. Additive intelligence is a consulting and application development arm of the company. It was established 5 years ago in its German operations, and this team leads companies through a step-by-step process that covers everything from a use case selection through material development and manufacturing. Our next DED solution comes from Formalloy. This one has me intrigued. It's called Project Sidecar, which is about rapidly deployable in-theater metal part production and repair. Others are tackling the military deployment of additive manufacturing, but Formalloy has a unique element in the solution to eliminate the hazards and hassles of dealing with metal powder. It enables safe, efficient, and fast conversion of bar stock to 3D printed metal parts. Formalloy's DED system utilizes powder made directly from bar stock on demand to eliminate the need to store and handle that powder. I have no idea how they make this happen, but I will be investigating. Sticking with metal AM, let's shift to powder bed fusion and the new XM200G series from Exact Metal. XM200G aims to make high-speed metal 3D printing available for more customers, with a price starting at $90,000. Versus the XM200C, which I believe was discussed at RAPID TCT 2021, the G-Series has high-performance galvo systems for faster prints and dual laser capabilities. Whether you opt for a single or dual laser, you get the option of 100, 200, or 400 watt lasers, a build volume of 150 by 150 by 150 millimeters, and integrated powder handling. And the last highlight for metal additive manufacturing comes from Tritone Technologies. Its new approach, called Mold Jet, blends jetting and extrusion in a 6-stage carousel-based process. The key steps to understand are that a layer of soluble mold is jetted. This is then followed by an extrusion of a metal-filled paste into the cavity. Layer by layer, that process is repeated. After printing, the mold is dissolved and the parts are debound and sintered in a separate furnace. So why would you take a look? Well, compared to binder jetting, the company claims crisper details and better surface finish, and higher alloy concentrations in the green parts, which means less shrinkage in the sintering furnace. Also, straightforward material handling. You can swap materials in less than 15 minutes with no exposure to metal powder, so PPE and filtration are not required. This process includes layer-by-layer inspection using AI algorithms. If a fault is detected, the layer is removed and repeated. The machine is called Dominant, and Tritone plans a 2023 commercial release. In the non-metals category, WASP has 2 new printers based on its liquid deposition modeling, or LDM for short, which uses delta motion control. These were announced in late 2021, and I believe this is the first display in North America. The first printer is the WASP 4070 HDP, which will be released this month. HDP stands for High Definition Pellet, and as the name suggests, they are going after feature detail and finish with a pellet-based process. The build volume is 400 millimeters in diameter by 600 millimeters tall, and the granule or pellet capacity is 5 liters. The second printer is the WASP 4100 Clay with continuous feeding. This printer isn't new. It's been available for 3 years. What is new is the continuous feed system that allows you to replenish the clay during the printing process. Yes, it can print clay, but the primary target is the production of ceramic parts. Oh, and by the way, the company also mentions refractory metals. This machine is based off of the same platform as the 4070, so its build area is a diameter of 400 millimeters, but elimination of the heated build plate increases build height to 1 meter tall. Sticking with granule-fed polymer extrusion, Juggerbot 3D has 3 announcements that will be on display. The first is fused granulated fabrication duplication mode. Actually, that is one application for the first ever FGF dual extrusion system. Doing twice the work in the same amount of time increases throughput, but the dual extruders also support multi-material builds. Second up is the Model 19 pellet extruder upgrade. This is for its Tradesman series. The Model 19 extruder offers support of nozzles up to a 10 millimeter orifice for faster printing. It also improves uniformity in heating and mixing. And finally, we have bead characterization system. This helps operators efficiently identify parameters for the optimal flow rate of a specific material and machine combination. Also in the material extrusion category is Linkster with 2 new printhead options for its S6000D printer, which is modular and supports interchangeable toolheads. With the LIQ11 and LIQ21, you can print thermoset materials that don't require UV curing. This opens the door to silicones, polyurethanes, and more. And this is in addition to what it can already do, which is thermoplastic filaments and pastes. By the way, the S6000D platform is similar to the WASP 4070. It uses delta motion and has a 390 millimeter diameter by 600 millimeter height build volume. Pantheon Design will launch the HS3 high-speed extrusion 3D printer at RAPID TCT. This unit addresses speed and quality in a reasonably priced unit starting at $8,000. The company says that this is the result of ground-up redesign with the goal of serving those that just want their 3D printer to work well. The company claims 3 to 5 times the speed of competitive units and cites its new extruder as being outfitted with closed-loop controls and nozzle contact probing while printing at flow rates of 120 cubic millimeters per second. Now I turn to material jetting. Quantica invites you to stop by to learn about its printhead technology, which can jet materials that are 15 times more viscous than the norm for material jetting technologies. The company states that it can reliably jet materials beyond 300 centipoise, at temperatures up to 100 degrees C. This opens the door to new materials with a wider range of properties. Presently, the printhead technology is functioning on an application development platform, but Quantica has stated that it will be releasing information on its new Jetpack just prior to RAPID TCT. Jetpack will be a solution for testing and development specifically designed and optimized for drop watching of materials that can be jetted with the new printhead technology. The second of our entirely new solutions comes from BCN 3D, which you may recognize for its FFF printers. I'd say this belongs to the VAT photopolymerization category, but could be persuaded to list it in sheet lamination. The reason it has no clear home in the ASTM categorization scheme is that there is no VAT and the raw material is a viscous fluid, not a sheet. The process is called viscous lithography manufacturing, or VLM. In short, resin coats a transfer film that is located above the build area. Then the build plate, or previously printed part, is brought up to that transfer film. Using an LCD panel, UV light then cures the layer. Since the transfer film can be coated from either the right side or the left, dual material printing is possible. Like Quantica, BCN 3D is addressing viscosity limits to open the doors to more materials, including filled materials. The company claims that it can use resins that are 50 times more viscous than the usual photopolymers in the additive manufacturing realm. Sticking with photopolymerization, I bring you Nexa 3D's ZIP desktop printer. ZIP uses the company's lubricant sublayer photo curing, LSPC for short, and delivers print speeds of up to 18 centimeters per hour, offering a 4.8 liter build volume and high resolution generated by a 4K LCD panel. Other features worth noting: it's a fully open material platform, it has quick and easy resin loading, and you can do that during a print job. It uses smart resin cartridges for touch-free loading and intelligent resin leveling, and has a toolless VAT system that clamps in place with electromagnets. The last printers in the roundup are Carbon's M3 and M3 Max, both of which use the company's digital light synthesis technology. These are a further evolution of the company's M-series line of printers with a focus on throughput and new capabilities. The difference between these models is in build volume. The M3 maintains the capacity of the M2, which is 7.4 by 4.6 by 12.8 inches. Now, using a 4K light engine, the M3 Max has double the build area with the same resolution as the M3. Highlights of both include improved thermal management to accelerate printing by up to 2.5 times, lower force imposed on parts, plus closed-loop temperature and force control to reduce failure modes, and improved part-to-part consistency. Sticking with Carbon, I'll transition to software with a highlight of its design engine, which automates the design of complex parts with complex structures like lattices. Now, design engine isn't new, but what is new is that Carbon has made it available to all, whether you have a Carbon printer or not. The primary goals of the software are save time and energy in design, easily iterate designs, and produce tuned lattices that meet specific mechanical, aesthetic, and other design requirements. Sticking with the design aspect, we have Core Technology and its 4D additive manufacturing suite. This is a standalone package that uses intelligent BREP, or boundary representation, geometry to optimize CAD data for additive manufacturing. So you start in CAD and then you turn to the 4D additive software to optimize for minimizing printing time while yielding the highest quality finished parts. Additional capabilities include healing, texturing, labeling, variable density lattice generation, nesting, and support generation. So we've covered two-part design and preparation software solutions. Now let's move to process development and optimization with Exponential Technologies XT AMI. This is a platform for intelligent printer parameter development that can reduce R&D time by up to 95% and print times by 25% while delivering better results. This data science platform puts advanced capabilities in the hands of any engineer. XT AMI is easy to use, doesn't require statistical or programming knowledge, and fits perfectly into any existing workflow. A key element is that it allows you to reduce the number of test builds by learning from past experiments and data points. The bottom line, according to the company, is that XT AMI brings users as close to first time right as possible. Moving on to printer operations, we have AddUp and its dashboards for process monitoring. This is the first in AddUp's full suite of monitoring software to close the loop on AM processes. This will be followed by recoat monitoring and melt pool monitoring later this year. Dashboards is an option with any AddUp machine that collects all production data in real time and presents it in a dashboard format that is customizable for different user needs and preferences. That data then is available with a simple click to view current and historical information that drills all the way down to the individual layer for any print or all the way up to show printer usage. There's been plenty of conversation around software with respect to effective workflows. Should we continue to rely on discrete specialist software for each step in the workflow, which means learning different interfaces and dealing with imports and exports? Or should we move to a data architecture backbone that provides hooks into the data and access to functionality to make the workflow seamless? And the latter solution allows specialist applications to function as a whole. Well, Besetti's Tixma provides an alternative, an end-to-end solution in one modular package. Tixma for additive manufacturing R&D was released 2 years ago. Following the acquisition of 3D Trust 1 year ago, Besetti expanded the functionality to be the end-to-end software solution for design through implementation to production. Its latest release, version 5, improves the link between the portal for quoting and ordering and production. I'll now cover a few new additive manufacturing materials that you can see at RAPID TCT. AM Polymers has a new plug-and-play polypropylene for powder bed fusion printers, including both laser sintering and high-speed sintering using either fiber or diode lasers. It's called Relaserit PP01. This isn't the company's first polypropylene, but PP01 is its new budget-friendly variant. Part of the plug-and-play versus plug-and-pray promise is that PP01 recoating with a blade can be done without significant efforts on your part. And there's another Relaserit material that was born from a collaboration between Mitsubishi Chemical and AM Polymers. This one is a PBT named Relaserit PBT. Like the polypropylene material, it can be used on a variety of PBF machines with a plug-and-play approach. Relaserit PBT powder delivers excellent mechanical properties such as low water absorption, UV stability, and impact strength. It prints easily without the need for high-temperature printers. The material will be rolled out in North America this year. The final material I'll highlight comes from Infinite Material Solutions. Aquasys GP, the GP stands for General Purpose, is a soluble support material for low-end desktop fused filament fabrication machines. The company states that it is a high-performance support material compatible with conventional thermoplastic build materials and processes. It's a direct replacement for PVA and it is a room temperature, drain water safe, soluble material. The latter point is because it requires no harsh chemicals for support removal. We've covered hardware, we've covered software and materials. Now let's move on to post-processing and ancillary solutions. I'll start with post-process technologies and its latest in the line of FDM or FFF support removal solutions, the Vorsa 500. According to the company, it provides the fastest cycle times in the industry, reducing processing time by over 50% when compared to submersible tank systems, and it uses 1/2 to 1/4 of the energy needed for a wash tank. Vorsa 500 uses the company's volumetric velocity dispersion technology, which employs multi-dimensional spray coverage. The process is further enhanced with the company's software-driven finishing solution called Automated. In the ancillary category, Thought 3D will be showing off its DryWise inline filament dryer. This is a standalone machine to be used in tandem with a 3D printer to dry hygroscopic filaments in real time, which means while you are printing. DryWise preheats a segment of material in under an hour and keeps drying the filament in line while you are 3D printing. The company's goals are to reduce drying time, which can take 4 to 10 hours if you're doing it in the typical cabinet, provide confidence in print quality with consistent moisture levels, and reduce energy consumption. BOFA also has a companion product for your 3D printers, but it isn't moisture that it targets. Instead, it tackles fumes and particulates, or in its words, atmosphere management. On display will be the 3D Print Pro HT for high-temperature polymer printing and AM400 for metal printing. The 3D Print Pro HT is the first for high-temperature, up to 230 degrees Fahrenheit, fume extraction, fumes that can be unpleasant or hazardous. It also circulates air within the build chamber to prevent particulate buildup on parts and printer components. The AM400 is for particulate, or condensate, removal in metal AM processes. It can be used standalone or integrated with your metal additive manufacturing machine that is running with argon or nitrogen. The key benefit is that the filters can be exchanged without risking a thermal event. That means fire or explosion, while being easy for the operator. The AM400 also features long filter life. Now I'm going to move on to 3D scanning solutions from 6 companies. AM Flow has extended its post-print automation solutions with AM Quality, which was developed in collaboration with Octon. AM Quality is a standalone quality assessment solution that provides geometric assessment in under 2 minutes, with an accuracy between 0.1 and 0.5 millimeter. It uses structured light scanning technology. And if it's like the balance of AM Flow solutions, it will feature automatic or semi-automatic part identification. The company states that this is the first in a series of quality assessment solutions that it is developing as part of a fully end-to-end digital additive manufacturing production line. Polyga Compact S1 is the newest in the company's line of compact scanners. This unit offers affordable entry-level scanning. And there are 2 versions, the S1 and the S1 Wide, which doubles the field of view and compatible part size. Both of these models capture 2 million points. The S1 does that in half a second at 35 micron accuracy. The S1 Wide does it in 1.4 seconds at 40 microns. Regarding affordability, I believe the price is between $3,000 and $6,000, but you'll have to confirm that with them. Faro Technologies will be showing off its all-new Quantum Max scan arm, which features 3 purpose-built, hot-swappable laser line probes. What that means is that you can swap a wide field of view probe for one that captures fine details without interrupting your workflow. Each of the laser line probes, the XR, the XP, and the XS, is enhanced with Faro CLR, which stands for Continuous Light Reflection. And what that does, it allows the capture of high-quality scans from dark, translucent, and reflective surfaces. The Quantum Max scan arm is fully compatible with Faro Cam2 software and its repeat part management feature, which allows guided inspection routines to be pre-programmed. Next up is Kion's and its VL500 3D scanning CMM, which the company states is the first fully non-contact CMM. The scanner incorporates a turntable for one-click automated scanning. While you lose that one-click option, the scanner head is removable so that you can capture larger objects. The company states that the VL500 has 2 micron repeatability, and it guarantees out-of-the-box accuracy to NIST standards. Each unit comes with a calibration certificate, inspection report, and traceability diagram. What's more, there's a calibration board that you can use to verify that your scanner continues to produce accurate results. So far, we've covered laser scanning solutions. Now we'll turn to CT scanning. Just a few weeks ago, Lumafield came out of stealth mode, and it will be at RAPID TCT with its Neptune CT scanner and Voyager analysis software. The company's aim is to make CT scanning accessible by eliminating the upfront investment and maximizing ease of use. On the investment side, the company is using a hardware as a service model with monthly prices starting at $3,000. On the ease of use front, Voyager, which is cloud-based, provides the know-how and expertise. Targeting and reverse engineering and CAD comparisons, Neptune has a scanning envelope of 155 millimeters in diameter by 300 millimeters tall and an accuracy of 25 micron. The X-ray source has enough energy to punch through plastics and some metals, so long as the thickness is reasonable. You can now reserve a Neptune with expected delivery to be in the 4th quarter of this year. I'll close out this video with a new CT scanning system from Pinnacle X-ray Solutions, the PXS CT600 production system. There are 2 models available, Type 2, which can handle parts up to 6 inches in diameter by 24 inches tall, and the Type 4 with a capacity of 18 inches in diameter by 24 inches tall. Both have plenty of energy, 600 kilovolts to be exact, to scan multiple parts at once or to see through high alloy parts like those made in nickel or Inconel. And it can be fast, with scans taking as little as a few seconds to a few minutes. This is a metrology-grade system for inspection of your production output, and it can be used in line with your manufacturing processes. A few other points of note. The PXS 600 can be outfitted with multiple robots for automated handling. The process can be completely automated for reporting on things like porosity analysis, CAD to CT comparison, and wall thickness analysis. Now, I've only scratched the surface with respect to the details of each of these new solutions and with respect to all of the new products on display from the nearly 400 RAPID plus TCT exhibitors. So now it's up to you to map out your show floor plan to see the solutions I've mentioned, to discover the solutions that are established, not new, and to sniff out other printers, materials, software, ancillary equipment, and 3D scanners that will be announced or launched from the RAPID plus TCT show floor. I really hope I get a chance to see you there.